Mr. Mills?
What?
I do.
No. We're doing domain and range. We started talking about this. We started talking about this the other day. This isn't entirely new, so it shouldn't be too terribly difficult. So we're going to hopefully go through this quickly. Okay. The first thing is this, our first example, and again, this is review. If we're given f of x is equal to 2x minus 5, and we have the domain -3, -1, and 7. Okay, I'm pretty sure Mariah did one of these problems on the board the other day for the review. How do I find the range?
Plug in the domain and solve.
Okay, I'm going to plug in my domain and solve. So tell me the first one. Let's see. Go ahead.
It's f of -3.
So JD says f of -3 equals
2 times -3.
2 times -3
Minus 5.
minus 5. Now, please make sure you're taking notes. These notes go into your binder. So when we do a binder check towards the end of the 6 weeks to give you an easy test grade, you should be able to get 100. But you have to have notes. Okay? Now, quick question. Am I going to do anything with that?
No.
No, that's just going to stay there. Okay? So I'm going to have f of -3 equals, and now simply on this side, I'm going to, what's the word I use? What am I going to do here? Simplify. I'm going to simplify from here. Okay, so 2, and again, order of operations is important, which is why that's the very first thing we did when we started school. So what is 2 times -3? -6. I got to multiply it first, right? So -6 minus 5. So f of -3, if I continue to simplify, is -11. Very good. Guys, please don't be afraid to use your calculator if you have a hard time with, adding and subtracting integers. All right? Again, the biggest thing that makes me laugh about students is their embarrassment or their lack of willingness to use a calculator. But truth be told, in 4 years from now, 5 years from now, 6 years from now, when you're in the real world, you'll be busting out your cell phone calculator like nobody's business when you're an adult. Okay? Unless you're Mariah and you don't have a cell phone and you're doing this. 30, 60. Okay, all right. I know you do. They teach you that in elementary. Okay?
Hey, I wasn't done.
All right. All right, moving on. Okay, let's look at another example. Now, we're not changing a whole lot. Very similar concept. All right, very similar concept to what we just did. Now, if I'm given the f of x equals -3x plus 1, if I'm given the range now, this becomes a little more challenging, slightly more challenging, of -2, 1, and 7. What do I do now to find the domain? What do I do? Okay, so instead of plugging in the x value, I'm going to plug in this entire function, the f of x. Remember, what does range deal with? The y values. How can I rewrite this? Y equals? Yeah, y equals -3x plus 1. If I rewrite it like that, it makes it a little more easy to say, okay, if I'm dealing with my range values, which are y, I can plug those in for y now and then solve for what? Solve for x. So now I have -2 equals -3x plus 1. Okay, so what do I do to solve? Okay, subtract 1 from both sides. What are you confused with? All we've done so far is taken this equation out of function notation, put it in a more linear notation with this y equals. We just changed this because f of x, remember, and you might put this in your notes, f of x is the same thing as y. They're both the dependent variables. Okay, they're both the dependent variables, so I can switch them in and out if I need to. So I switch these out, And then I replace the y values because this is my range. So it's all my y values. I replace that, the first one, with -2 so that I can solve for x. And I end up with what here?
0.
No.
Dang it.
-3 equals
3x.
-3x, right? Because these cancel out.
Okay.
Okay, now what do I do, Kirsten, to solve for x?
Don't you have to get x by itself?
Yes, so what do I do to get rid of that -3?
Divide 3 from both sides.
3?
-3.
Divide both sides by -3. Very good. So dividing both sides by -3 cancels that out. Essentially cancels that out, but it doesn't really cancel it out. It makes it what?
0.
Not 0. 1. Remember, same number in the numerator as the denominator. Okay? It's a whole, right? So it's 1. So 1 equals x. Okay, so my domain so far is going to be 1. And we didn't do this with the other one because I knew you could go through all of this. So we're going to go ahead and continue to solve. What do I do now, JC?
And you would plug in the next y value.
Okay, so set it up for me.
It would be 1 equals -3x plus 1.
1 equals -3x plus 1. Does everybody see where she did that?
Yes.
Okay. What do I do next, Caitlin? Huh? As opposed to Caitlin? No, I said Caitlin, but anyhow, we're taking a lot of time from her.
Okay, anyways, you subtract 1 from both sides.
I subtract 1 from both sides. Again, I'm trying to get everything away from the x, very much like what Kirsten just said. What does that leave me with, Candace? When I do this, when I simplify this, what does that leave me with? 0 equals what? -3x. Okay, what do I do next now, Preston? Divide both sides by? -3.
Now is it going to be 0?
Now you're going to have 0 because 0 divided by -3 is 0 equals x. So our next number is 0. So we've got one more number to do for domain. So what do I do now? Let's see. Let's see. Go ahead, Kaylee. What do I do next?
You
7 equals -3x plus 1. Kira, what do I do now?
Where'd you get the 7? Oh, wait, just
Yeah, so now I'm working on this number, right?
yeah,
Okay.
you subtract the 1.
I subtract the 1 from both sides. Okay, what does that leave me with, Eric? 6 equals -3x. That cancels out there. And Zach, what do I do now?
Divide -3x for both sides.
Not 3x, just -3. Divide both sides by -3 on both sides. I end up with, what's 6 divided by -3, Rhiannon? -2 equals x. And so then I stick that in there. And there's my answer. When you're doing a problem like this, you're going to have to do it 3 times in order to find your answer. Any questions there? So the first one we found the domain. The first one we found the range by plugging in the domain. So essentially we found the y by plugging in the x, which is easier, right? Because we just plugged in the x simplified. We didn't have to solve anything. This one we found the domain, or we found the x value by plugging in the y value, and this time instead of just simplifying, we actually had to solve for x. 2 different things. We simplified for one, solved for the other. Okay? Any questions? Alright, let's look at our next example. So that was domain and range. We're going to talk a little bit about intercepts again. So this will be our intercepts section. Okay, so tell me again, when you're dealing with, what is an x-intercept? It's where the what crosses the x-axis? I'm sorry? Okay, we don't call it a line anymore. Where the graph, or the graph of the equation, where the graph of the equation crosses the x-axis.
Or touches.
Huh?
Or touches, right?
Or touches. That's very good. That's a good point. Nathan makes a good point. Now, we're going to have x-intercepts every now and then, especially when you're talking about absolute value graphs, or you're talking about quadratics graphs. You're going to have x-intercepts that actually don't cross the x-axis, but instead, what they end up doing is they just touch it. Okay? When we deal with our real life, and I put that in air quotes, real life scenarios, because they're not really real life. When you put those in your real life scenarios, we only use quadrant 1 a lot of times. And so that initial value is the y-intercept. It'll start there, and then everything will go off that, and it actually doesn't cross the y-axis. It just kind of hits the y-axis. So very good. So that probably isn't the best terminology to say it crosses. More or less hits, right? What else do we know about x-intercepts? What do we know about the ordered pair of an x-intercept? You got it? The y value is 0 for every ordered pair. I had a feeling you were going to say that. I really did feel that. But you didn't want to say it. Don't be scared. This is a safe place.
I thought I was going to get it wrong.
Don't worry about being wrong, all right? You don't learn anything if you don't get something wrong. Y value will be 0. In the ordered pair. What other names do we have for x-intercepts? They're called zeros. What else? Solutions. What are they solutions for? Does anybody remember? Because we won't use the terminology solutions right now. What? Let me know what solutions are called. What are the x-intercept solutions for? Nope. What if I start with that? Quadratics. They're the solutions of your quadratics. Okay? So we got solution, we got zeros, solutions, what else? One more name. Starts with an R. Plants have them.